So we just obtained expressions for the energy for relativistic system, E equal gamma mc squared, and for their momentum, P equal gamma mv. What we often need in order to describe the kinematics of, for instance, relativistic collisions is a relationship between energy and momentum. So for that we rewrite this expression by squaring them. For the equation for the momentum, we multiply by c squared and we add on both sides m squared c4. Factorizing gamma squared m squared c4 on the right hand side, we can write. We now show that the term between the brackets is just 1. So both equations are equal to gamma squared m squared c4. Therefore we can write that E squared equal m squared c4 plus p squared c squared. This is a very important relationship which is used a lot in order to determine possible momentum and energy of final products of a collision of particles, for instance, or for decays of particles. We are also often interested into the kinetic energy. So for non-relativistic systems, the kinetic energy is just half mv squared. But we saw that for relativistic system we have also a mass energy term, and half mv squared is only a small velocity limit of the kinetic energy. So we will use the same definition of the kinetic energy as the difference between the total energy and the mass energy mc squared. So we have E equal mc squared plus k. So when the system is clearly relativistic and the velocity v is not particularly small with respect to c, we have k equal to square root of m squared c4 plus p squared c squared minus mc squared. We sometimes also have cases where the particle is ultra-relativistic. So what it means is that its velocity is very close to the speed of light. In this case, gamma goes to infinity. Therefore, the mass energy becomes negligible with respect to the kinetic energy. In this case, we can approximate the energy to being equal to the product of p times the speed of light c. In fact, that's the expression of the energy for a photon, which is a massless particle of light. And in this case, of course, we have no mass energy term.